Sure. Is that correct? So you could sketch it if you wanted to, right? Where's 1, 0? Let's sketch it. 1, 0. I don't know where is 1, 0, x is 1, so it's right about like right. I think that's 1. Is that correct? That's 1 on that graph, right? When you make your slope field, that's where 1 is. Because when you plug in 1, 0 into that, plug in 1, 0, what do you get? What's y prime at 1, 0? 1. It's 1, right? So look, you look at this slope field, and then on y equals 1, what does it look like if you plot the solution, meaning actually find the path of the boat, so to speak? What's it going to look like? Sure looks like that to me. So what's the equation? What's the slope? 1, and then you have the point 1, 0, so it's y minus 0 equals 1 times x minus 1. So it looks like it's y equals x minus 1. Done. Now, you have to do it that way. Why do you have to do it that way? Or why is that the easiest way to do it? What's the other way you could theoretically do this? What's the other way you could do that that is a lot harder? You could try integrating, right? So did you try integrating this? Yeah. So you had dy dx, and you had, what is it? Is it x minus y? Yeah, x minus y. Can someone tell me what the challenge is if you try to integrate this thing? Yeah, it's not separable. It's not separable. If you try to integrate this, you're going to run into a wall real quick. If it was x times y, yay, which is seemingly more complicated. But x minus y is not a separable differential equation, so therefore it's not something you can integrate. Does that make sense? So if you plot it, you're stuck on that line. Fantastic. You'd be using what? You'll be using your calculator. But you can do these by process of elimination. You can do them by process of elimination. I'm not going to do them out. The answer key is in there and tell you how to do it by process of elimination. But there are key differences between all of them that you should be able to figure out. There are key differences between all of them that you should be able to figure out. Use the differences and use process of elimination to match these all. It is not graph A, graph B, graph C, graph D, E, and F, and then match them. Do not do it that way. You can get slope field programs on your calculator. I think they're a little bit of a waste of time. There's a reason why you get more time per question for calculator questions on the AP exam. Do you know why? What kinds of lines are those? Horizontal lines. So in terms of n, what's the equation going to be? What? Y equals n. Done. 做完了. Done. You plot the points. You draw the lines. You notice all of them are horizontal. You notice all of them are horizontal. Why is it n pi? Oh, excuse me. It is n pi, isn't it? Sorry. You're right. You're absolutely correct. I'm very sorry. It is n pi because it goes to pi and then 6. Excuse me. Yes, you're absolutely correct. Yes. But then you're done at that point. How could you prove that, though? We just did it by looking at the slope field and going, yes, it looks like it is. How do you prove it? Come on, kids. How do you prove it? What could we do? We can separate. Is this separable? Yes, dy dx is equal to sine x sine y, right? It is separable. We have an initial condition. That's a bunch of initial conditions. But we have sine x equals sine y. So what does that mean? We have dy over sine y is equal to sine x dx. What do you do to both sides? What do? You integrate both sides. So if you're going to integrate both sides, the right side's pretty easy. What's the integral of sine? What? I like negative cosine x. Nice. I'll put the plus c over here. What about the left side? So what point are we starting with?
0, 0.
Yeah, we're starting with 0, 0. Nice. So we start with 0, 0. And what's our delta x? 0.2. Is that correct? Yeah. Nice. Okay. So what is our slope at that point? What's the mark going to be?
0.
Why 0, Kevin?
X cubed minus y cubed.
Is in this case going to be 0. Yep, the slope is 0. Nice. What's our new x value? It's 0.2, right? It is 0.2. Did we go up any? Why not? Yeah, so we do this. Our delta y at that point was 0. So it's going to be 0. Our delta x stays at 0.2. Our delta x stays at 0.2. So what's our slope going to be now? What's our slope going to be now? 0.08. Yes. What? Absolutely, because it's 10th twice, because it's cubed. 0.008? Okay, so how do you get your delta y? What do you multiply together? That is delta x times the slope at that point. So what's it going to be? 0.2 times 0.008. What does that equal? 0.00 what? Is it 0.0016? Do this for me. Take out your calculator. We need some people tracking along with us. Is this correct? Thank you. Thank you. So now, what's our new what's our new x value? We actually know what all the x values are, right? The x values are pretty easy to find because they just go up by how much? 0.2. So we have 0.4, 0.6, 0.8, and 1. And what's the delta x every time? 0.2, 0.2, 0.2, and 0.2. So how do we find the next y value? What is the next? Oh, it's right there, isn't it? What is it? What's our next y value? 0.0016, like that. So how do we find the slope at this? What's the slope this time? What do we do? It's going to be 0.4 what? Cubed plus what? Oh, is it minus or plus? Minus 0.0016 cubed. Right? Can someone just tell me what that decimal is? Can someone tell me what that is? 0.064. Is that correct? Do we get agreement on that? Everybody hold your calculator over your head right now. You have 10 seconds. Do we agree with this right here? Is this repetitive? Does this go over and over again? Absolutely. This is absolutely the most steps I would ever have you do by hand. This is absolutely the most steps I'd ever have you do by hand. I would never have you do more than that. So you keep on doing this, and what do you end up with right here? This is the target of our work right here. This is the target of our work right there.